In this video, I will show you how to graph XRD data using Microsoft Excel. So in this sheet, we have two sets of data. First is aluminum oxide and zirconium oxide ceramic. And the second set is aluminum oxide with yttrium doped zirconium oxide ceramic. So we can begin by inserting a graph. We will insert a scatter plot. I recommend for XRD data using the straight line scatter plot. I never use the smooth lines for any of my graphs, only straight lines or with the markers. And we will select the first set of data. We can go to add the series. We will add first the 0% doped sample. Select the range of X values. So you can click and drag to select the entire range. You see we have a bit of data here. Okay. And do the same thing for the Y values. Okay. And so here is our first set of data. Now for graphs, typically we do not include a title above the graph, so we can delete that. Also, I've seen many publications and I've never seen them use grid lines inside the plot. So I also recommend removing the grid lines. It makes it a little bit more clean if there's no grid lines in the background. We can also format this graph to make it look a little bit better. I typically put a, you can double click on the plot to bring up the format. I put a border around this graph area, okay? And then we also have to make these axes the same color. So we'll make that black. Oops. Okay. I also typically remove the border around the outside of the plot. So if you just click on the figure, select the outside, and you can say no line. So it removes the border around the background. That way when you copy it or put it into a manuscript, there's no box around it. It looks a bit more sharp that way. We can increase the font. I typically use 14 or 16 point font. We'll go with 14. Also add tick marks. You can put them on the inside or outside. It doesn't really matter. Just keep it consistent within your manuscript. So I'll do the outside here. Eventually we're going to remove the y-axis, so we don't need tick marks on there. Okay. And then let's add a axis title. We're going to add, so you click on the figure, go to add, go to axis titles, primary horizontal for the horizontal title. We'll call this 2 theta degrees. Okay. Also, sometimes the font is not black for some reason, so we want to change it to black. There we go. For the plot size, typically I use a standard 4:5 ratio. So I'll switch the size, the height to 4 inches, and the width to 5 inches. And I keep that consistent among all my plots in the manuscript. Okay. So let's add our second series. We can go back to Chart Tools, Design, select Data. We're going to add another series. This will be, I believe, 2% yttria dope sample. The X values, so this time I'll show a shortcut. Instead of clicking and dragging, you can select the first value, press Control, Shift, and then the down arrow key, and that will select everything to the last value. And then the same for the Y values. Click, you can start from the last value, press Control, Shift, up arrow key, and then we can hold down the Shift button and select the down arrow key to select that last point. So we'll finish there. Say OK. OK. All right. So now it's important to organize the chart in such a way that it's meaningful to the reader. So right now, having these two data on top of each other, it's difficult to see the differences between the two. So one way we can separate or make it more clear is by separating these two patterns. So we can offset one of the patterns So to do that, we can add a number to the intensity values. So we'll make a new column here called I shift. We'll have a number to add the intensity to. We'll start with 100. So this first value, make a formula that says equals this value, the intensity value, plus this shift value. You say enter. If you click on the cell and double click on the bottom right hand corner, it will automatically populate that formula for the remainder of the column like that. Now there's a problem here because the next value, you see that this cell gets shifted down, and we want to keep this addition cell on C2 here. So we can fix it by adding to this formula at C2. We can add a $sign before the C and a $sign before the 2. Okay, and that will fix the column C and fix the column 2. So when we move this formula down the column, it remains, that cell remains constant. So we can repopulate this, and you see now it's always, no matter how far down, it always references this cell here. Okay, and then we can take that data. If you click on the plot, click on the plot you want to change, it'll bring up these blue boxes, and you can move this over like this. Okay, so now you can see it's been shifted over. We can add 1,000, maybe 1,500, and a little bit more, 1,750. That's about right. So now you can clearly see the two different plots. Okay. Also for XRD data, the intensity is arbitrary units. We don't need to have this y-axis, especially now that we've shifted it. The y-axis is meaningless, so we can delete this y-axis, but we can add a title to the y-axis. So axis title, vertical, and we'll call it, oops, intensity, and this has arbitrary units. All right, let's not forget to add a legend to this so we know which plot is which. So we can insert, add a legend, and we can put it to the right. Now I typically like to put the legend inside the plot area. So if we go to the legend, or just click on the legend, go to the formatting, the legend options, and then you can unselect show the legend without overlapping, and then that will allow you to put it right inside the chart area. Okay. Now let's talk about the different phases between these two sets of data. In the JADE analysis software, you should be able to find the reference peaks of the different phases. So we have aluminum oxide and zirconium oxide. And in class, you should have been able to determine that the aluminum oxide phase after sintering the ceramic is the hexagonal crystal structure. And then it also has the tetragonal zirconia phase, as well as a little bit of monoclinic zirconia phase, especially in the 0% yttria doped. And you can see that right here, these two small peaks is the monoclinic phase of zirconia. So we want to be able to point those out in your report so you can discuss those details between these two samples. So you should be able to gather the reference data of the phases, the reference phase. And so here's an example of the aluminum oxide, and this is from the JADE software, and it tells you where this data was published, what publication it came from, and it gives you the peaks and the angles and the intensities and the HKL planes of those peaks for the selected phase. And this one is corundum aluminum oxide, the hexagonal aluminum oxide. So there's different ways we can indicate these phases. One way you could do it is by adding an indicator to the plot. For example, I will copy this plot and we'll just send it into this sheet here to make it easier. So one way you could do it is add a marker. You can just, if you click on the plot and you go to insert, you can add a shape, and then that shape will stick with the plot. So for example, we can add a circle. We'll add this here. Let's make it, let's see, what does this look like? 0.05 inches. Is that too small? No, that's about right. And we can change the color. So we can make it black, for example. And then you can use these markers to indicate which peaks are, for example, the aluminum oxide phase. And you can go through the reference and find which peaks they are. So the first one is 25 degrees. Let's add, actually, before we do that, let's add some smaller tick marks so we can see that easier. Say yes, okay. And we can set that to 10 degrees. There we go. Okay, so the first peak is 25.7. So this is 30, 25. So this first peak is probably aluminum oxide. So we can put a little marker above that peak there. The second major peak, 35. Okay, so let's see, that's 30. So this peak is not aluminum oxide, this big one here. That must be the zirconium oxide. The next aluminum oxide peak is at 35, so this is probably aluminum oxide, for example. And I'll do a couple more, and then the rest you can do on your own. So 37.9 is another one. Let's see, probably this peak right here. All right. So that was 90, 50, 40, and we'll do the last one. The most intense peak is at 43 degrees. 43 degrees. 40, probably this one right here. So I've identified the first 4 peaks of aluminum oxide, and you can add a legend into your plot. If you insert a text box, for example, we can put it below our current legend, say AL203. Let's make this subscript. Sometimes Excel doesn't let you superscript or subscript. Should be a way. I can superscript, but I cannot subscript. That's fine. Oh, I figured it out. So if you highlight the number you want to superscript or subscript, you can right click on it, go to font, and then you have the option there. So you want to subscript that, okay. Font, okay. We'll say, specify that's hexagonal. Alright, oops. Make this the same size font, 14. Okay, and then we can add the shape to the legend. Okay, like this. Okay, so that's about right. So now you can add the other phases using the same method with a different shape. For example, I know that this peak, let's use a different shape actually. We'll do the triangle for zirconium oxide tetragonal. Let's see, 0.5. That's about right. We can have a different color. Gold. For example, I know this peak is the tetragonal phase, and then we can add another shape. We can use, let's see, square. With another color. Try gray. Okay. And then this is the monoclinic phase down here. Like that, for example. And then we can also add to this legend. This is tetragonal ZR02. And we're kind of running out of space for this legend. I'm going to move this down and then these items up. Like this. Looks a little bit better. monoclinic. You can align these text boxes if you go to Format. If you click on all three text boxes using the Shift key, you can go to Align, say Align Left, and then they all align to the most left. Same with the figures. If we can grab them, you can go to Align, say Align Center, for example. Align to center. Okay. You could maybe space this out a bit more. That looks a little bit better. I don't know, but that's up to you. So this is an example how you can distinguish the different phases of your XRD data using the icons. I'm going to show you another way. One thing to note is, now that you've put these icons and text boxes inside the plot, they move with the plot. But if you change the scale, for example, typically I don't add any white space on the left or right, but I forgot to on this example. If I change the scale, the icons and text boxes remain the same. So if you change the scale, you need to reposition all the icons. But another way you could do it could be a better representation is if you had this that shows from 10 to 90 degrees to theta, but you also have a second plot that you could put next to it with a narrower range that shows the difference in phases a bit more clearly. That could also be acceptable. For example, maybe we go between 20 and 40 degrees to theta, and so now we can see those monoclinic phases a little bit better. And you could do the same thing by adding the icons above those monoclinic phases to show that difference a bit more clearly. So that's one way of doing it. Another method you could try is overlaying these reference peaks onto the same plot. So you'll see the reference peaks, kind of like in the Jade analysis, you get to see the reference intensities when you find the phases. You can add it to your plot as well. This method takes a little bit more time, but in my opinion, it's worth it. So we can go through that together. Okay, so essentially we're going to add each reference as a series to the plot. I'm going to start with a new graph without the icons. Move this over. But in order to do that, we need to add a line before and after each of these reference angles. And so you'll see it's a bit time intensive, but we only need to do it between 10 and 90 degrees. So for example, we want to add 2 lines before that, and we'll add 2 lines after that. There's a shortcut. If you just select 2 rows and say insert, it automatically inserts 2 rows. So you need to do that before and after each angle or each peak of the reference, and you need to do that for each reference. So the zirconia reference, the monoclinic reference, has a lot of peaks between 10 and 90 degrees, but it doesn't take too much time, just about 10 minutes, I say, to add all these lines. And if you guys know an easier way of doing this, please let me know. I know you would be able to make a macro program with Excel to do this automatically, but I think the time I would take to invest in learning how to do that probably outweighs the time it takes for me right now just to do this. Uh-oh. Okay, I forgot. If you're inserting rows with your graph, the graph gets bigger. That's fine. You can just change this back. Okay, we just need to go up to 90 degrees. All right, now before and after each of these angles, you want to put the same angle, and then the intensity you will put 0. So that way, when you plot this, it will have a flat line at 0 intensity, and then once it gets to that angle, it will make a peak at that angle to that intensity value. So for example, the first angle, we can start with your data, which would be 10 degrees, and then this one will be the value before, and also the value after, right? And you repeat that for all of them. Now you could go through this and do it manually, and it wouldn't take too much time. Or you can make a formula real quick, especially for the tetragonal monoclinic phases, because they have a lot more peaks. It'll be faster if you make a formula. So we'll say this is angle, and this is intensity. Okay. And the formula you want to use, for example, we'll start this with 10. The formula would be if this value, let's see, if this value is greater than this value, I forgot the if B33 is greater than J30, then you return this value. Otherwise, return this value. Okay, I think that should work, and then we can delete these. That didn't work. Why didn't that work? Oh, that didn't work. Oh, excuse me. This is why it didn't work. Okay. Okay, and then intensity is just the same, like that. All right, so now if we add this to this graph, we'll call this the, what is this, hexagonal L203. Here's X values, here's the Y values. Okay, we can't see it because the intensity is so small. So we need to scale the intensity. We can say add this value. We can also multiply by a value. So the intensity is equal to the original intensity times this number. You can press F4, and that automatically puts the $signs in to lock it in space. Plus this value, press F4, locks it in. Okay. Okay, now we start to see it. Oops. That's not right. Let's take a look at the formula again. Oh, so I had this on the wrong cell. I had it on D spacing, so that's why you see it decrease with 2 theta. All right, so now we see our reference peaks for aluminum oxide. We can scale this down a bit. I'm going to go back and shift our data up. So I'm going to cut this graph, go back to the data page, so we can see it better. We're going to shift this up, say 5,000 start. Let's add a value for the other series. Shift equals this plus this. Remember to add the $signs or press F4 to lock it in place. And okay, and then you can click on that series and then drag the box over. So there's our 2 series of data, and then our reference peaks for aluminum oxide. we'll do the same thing for tetragonal monoclinic oxide or zirconium oxide to add the references in, and we can rearrange it after we add that. I have already, before the video, I went through and I already added the extra lines for these phases because I knew it would take a little bit of time. So we can add another series. This will be tetragonal zirconium oxide. Here's the angle. Here's the intensity. Okay. Add 100. Oops. We'll do the same thing for the monoclinic phase, which I've already arranged before the video. Let's see. Monoclinic zirconium oxide, 2 theta angle, and the intensity values. Okay, we'll put these on the same starting point. Alright, so there's our 3 reference phases in our 2 patterns from our data. So we can arrange this a bit better so it looks nicer. We could, might be okay to leave all the references aligned like this as long as the intensity values are relative. So from the reference data from Jade software, it gives you the intensity as a percentage right here. So the highest is 100%. So if we multiply one by 5, for example, the other ones should also be multiplied by 5. Or we could offset these a bit. So for example, maybe we offset this, let's say 300, maybe 500, 750. That seems okay. Let's see how this looks. 500. Oh, and it looks like there's something wrong on this one here. So let's go to the end. Oh, I see the problem. There we go. Okay. That might be okay. Let's go back here. Go back to the data. Let's change this. So that's too close. That's better. That looks good. And then we can arrange the legend. One thing we could do, because I don't like having it spread out like this, you can delete these entries from the legend. If you click on the legend and then click on that entry and then press the delete key, you can get rid of them from the legend, and you could manually enter them as a text box closer. Okay, series 2 lost its name for some reason. It's 2% yttrium. Okay. Oh, I'm going to change the scale of the x-axis between 10 and 90. So it looks like that's missing something. I'm going to go back here, add another value here for 90 degrees. So that line goes all the way to 90 degrees. So it looks a little bit better. Oh. Change this. Okay. There we go. Okay, let's finish up this plot. It looks like we need to add the legend still. So let's space these out, the references, a bit so we can have room to add the legend for them. Let's see, this is fine where it is. I'm going to go here. I'm going to add a bit more space on the tetragonal phase of zirconia. 1,000. 1,000 is a bit too much. Let's do 50. Okay. Monoclinic phase. How about 1250? Okay. So that's 150, 750, 600. So I'm gonna make this 1350. There we go. Now the spacing is even. Okay. And go back here. Let's do 2000. 50. That looks about good. We can insert text box for these phases here. So this top one was monoclinic zirconium oxide. The middle one is tetragonal, and the bottom is aluminum oxide. Oops. Uh-oh. Okay. I'd prefer if the legend was the same size as this, but given our constraints, I think it's fine to leave it. Yeah, that looks good. Okay, one more thing. Let me just add the tick marks in. Outside, yeah. Change the scale of the smaller tick marks. So it's every 10 units. Okay, that is a pretty good graph. And you can see the different phases of which piece correspond to which phase pretty clearly. So obviously it's hexagonal alumina, tetragonal zirconia mostly, and then the 0% doped has a bit of the monoclinic phase, but not much of it. Okay, I'm going to show you one more thing, and that is importing the plot into your report or manuscript. So for example, we open up Word. This is your manuscript, for example, and we want to add your plot. So we can copy your graph and paste the graph. If you press Control or you select this, you can paste it as an image. Okay, so now if you change the size, everything stays in the same aspect ratio, and it's a bit easier to move it around as an image as well. I typically put this centered into your report, and then also I will add a caption that's connected to the figure. So if you can add a caption by right-clicking and going to Insert Caption. All right, so this is a figure. Say OK, and then you can add a caption. So this is XRD pattern of 0%. Y doped CrO2 Al2O3 ceramic, for example. Okay. And that's it.